This video is going to have a look at how do we calculate the missing angle of a right angled triangle using trigonometry. So by the end of the video, you should be aiming to be able to calculate the missing angle of a right angled triangle using a trigonometric ratio. So we can use trigonometry to calculate the missing angle if we have two known sides. So if we have a right angled triangle and we know what two of the sides are, we'll be able to calculate the missing angles. So the missing angle is calculated by using the inverse function. So the inverse of sine is sine, and we use a -1 as an indice. For cos, the power of -1 as well, and same for tan. So when you see these functions, it means we are finding a missing angle using trigonometry. And just a reminder on your calculator to use the inverse functions. They sit above the sine, cos, and tan button. So if you hit shift and then sine for inverse of sine, shift cos for the inverse of cos, or shift tan for the inverse of tan. So the steps for calculating the missing angle of a right angled triangle using trigonometry are very similar to those for finding the missing side. Step 1 is to label the sides. Step 2, decide whether we're going to use sine, cos, or tan based on that information. Step 3, write the formula. Step 4, substitute in the values from the question. Step 5 is going to be apply the inverse operation. So if it was sine, we'll do the inverse of sine. If it was cos, we'll do the inverse of cos. And step 6, write the angles, making sure that we include our degree symbol in the answer. So let's have a look at some examples of how we can apply these 6 steps to calculate the missing angle of a right angled triangle using trigonometry. So example 1, we want to find our angle of theta down the bottom using the information in the right angled triangle. So the first step is going to be to label the sides. So having a look at the specified angle, I've got 3.5, which is opposite the specified angle. So I'm going to label that opposite. And I've got the hypotenuse side of the triangle. So after I've labeled my sides, the next step is to decide whether it's going to be sine, cos, or tan. And considering I've got opposite and hypotenuse, I'm going to use sine. So step 3 is going to write the formula. So sine of the angle is equals opposite over hypotenuse. Step 4 will be to substitute in my values. So the opposite value is 3.5 and the hypotenuse value is 5. So sine of my angle is going to equal to 3.5 over 5. So now I'm going to apply the inverse operation. So my angle, my theta angle, is going to equal the inverse of sine, 3.5 over 5. It's important that you leave this as a fraction and enter it into your calculator as a fraction, to allow you to make sure you're getting the most correct answer. If you convert that to a decimal and then put the decimal and then round the decimal and use a rounded decimal in this inverse sine calculation, your answer might be off by a couple of decimal point places, which would mean that in an exam you wouldn't get all of your marks. So leaving it as a fraction and entering it into your calculator as a fraction. So now that we have the inverse of sine, 3.5 over 5, we can enter that into the calculator and we can write our answer. So theta is equal to 44.43 degrees. And because the question is asking us to calculate it to the nearest degree, my answer is going to be 44 degrees. So my missing angle in the right angled triangle is going to be 44 degrees. So let's have a look at a second example. And this time I want to calculate the theta angle for this right angled triangle. So going ahead, following the same 6 steps. Step 1, label the sides. So my 5 meter side is opposite the angle. My 11 meter side is adjacent to the angle. So I've got opposite and adjacent. So step 2, I'm going to decide to use the tan ratio. So step 3, write my formula for tan. So tan of the angle is equal to opposite over adjacent. So step 3 is going to be to write the formula. So tan of the angle is equal to opposite over adjacent. So substituting in the values from the question, my opposite side is 5, my adjacent side is 11. So tan of the angle is equal to 5 over 11. So apply my inverse operation. So my theta angle is going to equal to the inverse of tan 5 over 11. So putting that into my calculator, it is going to equal to 24.44 degrees, which is rounded to 24 degrees. So my missing angle in my question is equal to 24 degrees. So example 3, I want to find the size of my theta angle sitting here up the top. And this time it is going to be correct to the nearest minute. So not using degrees, but now we're using minutes. So we need to make sure we're doing that conversion on our calculator after we have found our answer. So step 1 is going to be label the sides. My 7.2 meter side is opposite the angle. My 3.1 meter side is adjacent to the angle. So because I have got opposite and adjacent, I am going to use the tan trigonometric ratio. So writing the formula, tan of the angle is equal to opposite over adjacent. Substituting in the values, opposite side is 7.2, adjacent side is 3.1. So tan of the angle is equal to 7.2 over 3.1. Step 5, apply the inverse operation. So the size of the angle is going to equal to tan -1, or the inverse of tan 7.2 over 3.1. Entering that into the calculator, it is going to equal to 62 degrees and 42 minutes. So the size of our missing angle in this example is 66 degrees and 42 minutes. So having a look at example 4, I want to find my missing angle, but this time it's going to be to the nearest second. So following through my trusty 6 steps, first step, label the sides. So I've got a hypotenuse side being my 55 centimeters, and my 42 centimeter is adjacent to the angle. So I've got adjacent and hypotenuse. So I'm going to decide to use cos as my trig ratio. Step 3, write the formula. So cos of the angle is equal to adjacent over hypotenuse. Step 4, substitute in my values. So my adjacent side is 42. My hypotenuse side is 55. So cos of the angle is equal to 42 over 55. Apply the inverse operation. So my angle is going to equal the inverse of cos 42 over 55. Entering that into my calculator, my answer is going to be 40 degrees, 12 minutes and 51 seconds. So there's some examples of how we can calculate the size of a missing angle using our trigonometric ratios.